Hey class, how's it going today? We got our first video talking about some actual examples from our practice sheet on energy, specifically around the idea of conservation of energy. So either having potential energy and having it convert fully to kinetic energy, or having kinetic energy and going up, like actually going up a distance, and then how far up can it go before it reaches zero and having full potential energy. So basically that kind of idea. So this is right off the practice sheet called Conservation of Energy in our teams. In this first video, I'm going to do questions 1, 2, 3, and 5. And there'll be another video for kind of the second half of this worksheet. So let's get right to it. Let's go into these first, like 4 of the first questions, and just kind of see how I tackle it, how I think about the question to go into it. All right, so if I do this, I want, no, not that one. This one. All right, here we go. So I have my formulas here: potential energy, mass times gravity times height. Okay, we talked about it in the intro video. And then as well as kinetic energy, 1/2 mv squared. So there's our two formulas that we're going to be using basically for the good start of this unit. And let's kind of go through this first question. So it says a 1 kilogram drop is dropped from a cliff 90 meters high. It's a 90-meter cliff, little rocks right here, and it's going to drop. Okay, it says after 20 meters, what is the kinetic energy? Now there's not just one way to do this question. There's a couple of different ways that you could do it. Okay, one way you could find the potential energy at 90 meters, and you could find the potential energy at 70 meters, and you kind of actually see the difference. What I'm going to do is basically this rock is dropping 20 meters. It doesn't matter if the hill was 20 meters high. It doesn't matter if the hill is 40 meters high. It doesn't matter if it's 90 meters high. If it drops 20 meters, that means all we really need to know right now is what's the potential energy when a rock is 20 meters high. So that's kind of what I'm going to do. I'm going to find the potential energy of like 20 meters. And so I have to go mass times gravity times height. So 1 times 9.8 times h. I have 20. All right, what do I have for that? I have my potential energy is 196 joules. So it says, what is the kinetic energy of the rock? Well, the kinetic energy after 20 meters is going to be this 196. Okay? Like, let's find the potential energy of all 90. Okay, I'll do the other way of kind of thinking around this. Just grabbing my calculator. If I go 1 times 9.8 times 90, I have at the very top potential energy of 882. If it goes all the way down to 70 meters, so if I go 1 times 9.8 times 70, at 70 meters, so now we're at 70 meters, the potential energy is 686. And if I minus these, I get this, 196 joules. And basically that means that like I've lost 196 of potential energy, which means that's how much kinetic energy I now have to have. Okay, so this is the kinetic energy. This is what it was at 90. This is what it is at 70. If you minus those, that's how much kinetic energy you have. Okay? Again, if you add this 196 and 686, you're going to get 882. In the sense of like, we haven't lost any energy. We've just converted it from potential to kinetic. Okay, and so that's the big thing. That's why we call it conservation of energy. I'm not losing energy. It's just going from one of the energy sources, like converted from potential to kinetic. Okay, so there's question 1. Let's go. Question 2. It says a ball. Okay, so mass 0.5. A ball is thrown vertically upward with an initial kinetic energy. So it gives me the kinetic energy of 25 joules. How high will the ball go? Okay, so basically how high will it finally get to? All right, and so basically what we want to do is we want to convert, like at the start, I give it a velocity so that it has kinetic energy of 25 joules. That's what it's saying. It's going to go to a height and eventually get to a velocity of 0. When it gets to that height, it's all potential energy. And that potential energy is going to be 25 as well, because it's gone from like full kinetic to full potential energy. So right here, we have kinetic energy of 25. When it gets all the way to the top where it stops and the velocity is 0, now kinetic's going to be 25, but my potential energy at the very top will be 25 as well. And so this is how we can figure out the height. We can use my potential energy formula to figure out that. So I know that potential energy is 25, so 25 must equal mass times gravity times height. This is 0.5, this is 9.8. This is what I'm trying to figure out. So when I do this, when I divide by 0.5 and I divide by 9.8, I get a height of 5.1 meters. So at 5.1 meters, this ball will have a velocity of 0, at least that's the maximum height, and then it'll start to come down, but that is the height this will get to with this mass and this much energy at the very start. Okay? So again, kinetic energy is all at the bottom. When it goes all the way up and the velocity is 0, it has transferred all of that kinetic energy to potential energy. And so that's how we can figure this out. All right, let's go to question 3. Question 3. And you'll notice that in the notes, I have the answer keys up there. My answer keys, again, are kind of done formula-wise, where all my helpful videos are done kind of how I would usually answer this question. And so that way you kind of get to see both sides. You get to see the formula-based one on the answer key. You get to see kind of the way that I go through my head and how I understand these problems, and then that's what I would put in my helpful videos. So if you want to see another side of these, like still same answers, but possibly more formula-based, you can go to the answer keys. Let's go to number 3 here. 1 kilogram ball, so we have mass, 1 kilogram, is dropped from the top of the building just before striking the ground. So like basically we're going to call like a millimeter away from the ground. The ball's velocity or speed is 12. So we have a velocity right at the bottom of 12 meters per second. So that's basically, that's your like full kinetic energy, your full velocity there. It says, what was the ball's gravitational potential at the very top? So what was the potential energy? It says, what was the ball's gravitational potential energy at the very top here? So I want to know what was my potential energy. Well, it's going to be exactly the same as what my kinetic energy is at the bottom. Again, if I find the full kinetic energy here, that kinetic energy is going to be exactly the same as the potential energy at the very top when the velocity is 0, when I'm still holding it there. So as soon as I find this and get my kinetic energy, that'll be my potential energy at the top. So let's find this. We have a velocity, we have a mass. That's all I need for my kinetic energy is mass and velocity. So let's go through this. Kinetic energy is going to equal 1/2 times 1, that's my mass, and then 12 squared. So when I go 12 squared, that's 144 times 1 and give it a half. I have a kinetic energy of 72 joules. 72 joules. And so if I have full kinetic energy of 72 at the bottom, at the very top, again, it would have had a 72 potential energy at the very top. And you could have used that to find like the height of what it went to. Okay, but the potential, all it's asking here is like, what's the potential energy? That would have been your potential energy, exactly the same as the kinetic energy at the bottom. Cool, one more question for this video. Let's go through question 5. Let's, 1 second, just want to make some more space here. Okay. Tarzan has a mass of 85. Mass equals 85. Okay, a velocity of 6. He grabs onto a vine and he's going to swing up. How high can he get to? How high is his actual like swing going to get? Okay, and so what we're going to do is we're going to find the kinetic energy. That's going to give us the kinetic energy at the very bottom. And again, that kinetic energy is going to be exactly the same as the potential energy for how high he's able to go. Because eventually, he's only going to be able to reach like a certain height because his velocity is going to go down to 0 because gravity is going to slow him down and his velocity will get to 0. And so when his velocity gets to 0, that height, that potential energy will be exactly the same as the kinetic energy at the bottom. So let's find his kinetic energy. So we have Tarzan, okay, running this way, finds a vine and he's going to swing up to a certain height. Okay? Let's find my kinetic energy first. So, kinetic energy equals 1/2 mass 85, velocity 6 squared. So 36 times 85, and half of that is 1,530 joules. So 1,530 joules. That is going to be the kinetic energy that he's running with. He's got a speed, so he has kinetic energy. This also means that my potential energy at the top, when his velocity gets to 0, is also going to be 1,530. So let's actually use this to find his height. So if I know that he has 1,530 here equals mgh. Okay, so mass is 85 times 9.8 times, I need my height. So I'm going to divide these two. So I just divide this by 85, divided by 9.8. And the height, Tarzan does not get that high. He only gets to a height of 1.84 meters. And so that's how we can kind of figure out our height there. All right, so there's kind of the start of our questions. In the next video, I'm going to show you how, even if you don't have mass, you can still kind of figure out some of these answers, because you notice they both have mass, and so they kind of cancel each other out. Same like in this question. If I didn't have mass here, I actually can still get the same answer, because I times it by 85 and then divide it by 85 over here. They kind of cancel out. But I'll show that in the next video a little more in depth. The next video I'll kind of go over 3 or 4 questions from the backside. All right, class. Thanks so much. I gotta do this first. All right, have a good one.